What's up, guys? This video I'm about to introduce to you is very special. You know why? Because the sample I'm gonna be looking at in this video is albino, an actual albino. That's right, it's not a carrier for albinism variants because I've seen a couple samples. There was, I think, one sample I've seen before. It was from Israel, a Chalcolithic Israelite sample who was albino. But this sample is actually albino. It expresses the phenotype of albinism. This sample, I swear to you, this sample is actually albino because it's got not heterozygous genotype, it's got homozygous genotype for albinism variation in OCA2. And it is not a miscall. It is not a genotyping error because those typically are heterozygous. Those result in heterozygous calls. In this case, the call is homozygous for albinism variation in OCA2. This sample is actually albino suffering from albinism. So we are going to look at the result of an albino Jew from Erfurt. Let's get into this video. Hello, my friends. In this video, we will be taking a look at the autosomal DNA results, predicted phenotype traits, and G25 results of a medieval European Jew from Erfurt. The sample ID is I14736. You can find it right here. It's I14736 from Erfurt Jews. This sample is actually a part of the reference group for medieval European Jews on illustrative DNA. Now, the date for this sample is somewhere between 12th and 13th century AD, so it's very early. This is some of the earliest samples, some of the earliest European Jews in Europe. This is around the time that Jews started to appear in Europe in general. So before this time, there were no Jews in Central Europe. There were only Jews in Southern Europe, in Italy, in Greece, but not in like Germany or Ukraine or Russia. So this is just around the time that Jews started to appear in Central Europe. So this is very early Jewish period in Central and Eastern Europe. Now, for this sample, in terms of what it resembles, it seems to resemble modern Ashkenazi Jews from Ukraine, Poland, Belarus, and Russia. So there is continuity between Jews who lived in 12th century Germany and modern Ashkenazi Jews from Ukraine. There's very strong continuity. And they actually are very similar. This Ashkenazi sample is similar to Ashkenazis from Germany as well. And further, out of non-Jewish samples, it's similar to Maltese, Sicilians, very south of Italy, Greek islanders, and various Sephardic Jews as well. So it's very similar to Eastern Mediterranean populations, which makes sense because Ashkenazi Jews are an Eastern Mediterranean populations. They are a mixture of Middle Eastern people with Southern Europeans. So that's what they are. They are a mixture of Italians plus Israelites. So when you mix Italians and Israelites, you end up having a population that resembles Eastern Mediterraneans. There is a meme, there is a pervasive meme online that Ashkenazi Jews are Khazars or Slavs or something like that, but that is completely untrue because as you can see, this Ashkenazi sample can be modeled as a mixture of Greek, Ashkenazi from Romania, and Tunisian. We can also model it as, actually, let's remove all the Ashkenazi samples. Let's remove all the Ashkenazi samples from the model, and I will show you what it looks like if you remove all the Ashkenazim from the model, and you will see what it looks like then. So yeah, if you remove all the Ashkenazim from the model, then the result is 40% Italian, 37% Greek West Taygetos, which I assume is Middle Eastern Greece, Middle Eastern Greeks, and 22.6% Bedouin. So essentially, this sample is very much Middle Eastern, very much Eastern Mediterranean in ancestry. Very much Eastern Mediterranean in their genetic results. So obviously not Slavic, obviously not Germanic, obviously not Turkic or Khazar. Very much Eastern Mediterranean genetics. Now we are going to examine what this sample scores with my trait predictor, and we are going to start with Nashakot and appearance. So for appearance, it looks like the sample actually has light eye color. Blue eyes at 27% odds, green eyes at 26% odds, and hazel eyes at 19% odds. That's the third most likely eye color. It looks like the prediction is not very definite. There is a 6.4% odds for brown eyes, so it's not a very definite prediction. Perhaps the file isn't very high quality, but there's still a very high percentage for blue eyes, which is definitely very interesting. For hair color, looks like this sample is actually scoring red hair, which is also very interesting. So this sample has got blue eyes or some sort of light eye color, red hair, and what's interesting is for skin color, he seems to be scoring light brown or olive skin tone, which is very, very, very surprising. For hair texture, no, that's a she. That's a she. Right, so it's a female, so it's a she. Her mitochondrial lineage is K1A1, right? Right, so it's a she. Let's return back to Nasha code. Right, so it's a she. And for hair texture, she's scoring curly hair, curly or wavy hair texture, right? And for nose shape, she's scoring definitely very Greek shaped nose, so definitely very aquiline, long and narrow nose shape, which is definitely very interesting. So Greek shaped nose, curly hair, darker skin tone, which is very, very, very interesting. Red hair and lighter eye color. Very, very interesting combination. Now we're gonna go ahead and look at her coloring variants that are found in the file, and we're gonna find out why she scores the way she does. Alright, I was glitching, so I had to close and open the whole thing again. So she's actually got heterozygous genotype in this variation of HERC2, which is very interesting. So she definitely would not score blue eyes with SNP3, probably would score hazel or green. She's got two light color variants in this variation of HERC2. This is blue eye haplotype 2. So she would score blue eyes with YSEC, but with SNP3, she would probably score green or hazel because she also has heterozygous genotype in this variation, which is blue eye haplotype 1. So yes, with SNP3, she would probably score green or hazel for eye color. But this also explains why she scores so dark for skin color with my trait predictor. But with SNP3 for eye color, she would probably score green or hazel actually. But she also scores 19% for hazel eyes, which and 6.4 for brown eyes, which is quite high in reality compared to blue and blue Lambert center and green. So she's scoring quite high for green and hazel with my trait predictor as well. Take that into consideration, actually. Now, okay, let's see what else. She does have two light color variants in this variation of OCA2, which is very interesting. There is no genotype for this variation of SLC2485. If she did have a genotype here and it was two light color variants, the skin color prediction might have been very, very different. If she did have a genotype here, but she doesn't. So that also contributed to the skin color prediction. She does have two light color variants here, which is very interesting. And let's see what else. And she does have these genotypes in MC1R, which are the reason she scores so high for red hair. Because of these variations in MC1R, she's scoring ginger hair. I am not sure if these are the variations in MC1R that cause that YSEC predictor looks for. I am not sure if these are the variants in MC1R that YSEC. Let's check it out. Would she score red hair with YSEC as well? Let's check this out. I don't really know. We can try to check this right now. We can try to check this right now. I think she would score. No, she scores blue eyes and blonde hair, but she does score 39% for red hair actually. Yeah, so she scores a lot for red hair. She scores 39.1% for red hair. So she scores a lot for red hair. Let's see. This YSEC does look for these MC1R variants. It does. But YSEC does not predict her to have red hair. YSEC predicts her to have 39.1% odds for red hair. Whereas my trait predictor predicts her to have a much higher. My trait predictor predicts her to have a 63% odds for red hair. So there you go. YSEC does not think she would have red hair, but YSEC thinks she has a very high odds for red hair. There you go. And also YSEC does not think she would have a light brown or olive skin tone. There you go. There's the difference. Now let's look at the phenotype oracle. And for the phenotype oracle, the closest phenotypes that show up here are these phenotypes. And the reason she's getting these phenotypes despite having blue eyes and red hair and all these light features is because she still has darker skin, right? And that is what causes her to score these phenotypes that are darker. It's because of the darker skin, and because of not having the having heterozygous genotype and blue haplotype 1, right? Because of that, she scores these darker phenotypes, right? So that's why she's scoring these Mediterranean-looking phenotypes in the Oracle. And by the way, I think you can notice that the phenotypes she scores have curly hair. This phenotype is curly hair. These have straight hair, but this phenotype right here has curly hair. This one has curly hair. This phenotype is curly hair. This phenotype is curly hair. So she's scoring phenotypes with curly hair as well. However, the phenotype with straight hair is a little bit closer to her than the phenotype with curly hair, which is very interesting. So here's a distance of 1.097, and here's a distance of 1.105. So the phenotype with curly hair is a little bit further from her than the phenotype with straight hair, which is very interesting to observe. All right. Okay, let's look at the biomarkers results for her. And for the biomarkers, looks like she's got higher levels of vitamin D, which is really good. Lower levels of LDL cholesterol, which is also really good. Lower levels of HDL cholesterol, which is okay, but you want to have higher. But it's still kind of within the general average range, so it's whatever. She's got higher levels of glucose, which is okay. She's got higher levels of hemoglobin, which is okay. She's got higher levels of blood pressure, which is bad, but it's still within the general average range. She's got lower levels of iron in the blood, so she does not have hemochromatosis. She's got higher levels of sex hormone binding globulin. She's got higher levels of red blood cell count in blood. That's typical. She's got slightly lower number of base pairs for telomere length, so she's got slightly shorter telomere length and shorter lifespan. And she's got shorter height, shorter expected height, so she's not going to be as tall as the average person. All right. Now let's look at the polygenic risk scores and predicted health and traits. We are going to ignore everything that is close to 1 and only look at the traits that are very distant from 1, either very much below 1 or very much above 1. So it looks like she has a very high odds for kidney stones. Well, not very high, but like slightly above average for kidney stones. Looks like she has a below average odds for arrhythmia nodosum, a above average odds for hemoglobin E disease, a below average odds for migraine, a above average odds for lupus. Very interesting. So perhaps she has a interesting score for the HLA gene panel, because that has to do with the HLA gene panel. She has a average score for gout. She has a average score for thyroid cancer. Okay. She has an average score for eczema. She has a very low score for exfoliation glaucoma. The other stuff for glaucoma I don't find interesting to talk about. She has a high score for cataracts. She has high score for age-related macular degeneration. She has high score for rheumatoid arthritis. She has low score for Tourette's. She has high score for epilepsy. She has average score for asthma. She has a lower score for vitiligo. She has slightly above average score for myopia. She has slightly below average score for corneal astigmatism. She's got higher than average score for male pattern hair loss, which is not surprising because Jewish people are very much stereotyped to be losing their hair at an early age. You know, it's a stereotype that Jewish men grow their beards at a very early age and get facial hair and get body hair uh, by the time they're like 14. But they also lose their hair on their scalp very early as well. So this is not surprising whatsoever. And she's got average odds for atrial fibrillation, and she's got below average odds for cardiovascular issues, and she's got average odds for ADHD, average odds for unipolar depression, slightly below average odds for bipolar type 1, slightly below average odds for schizophrenia. She's got slightly above average odds for type 2 diabetes, and she's got slightly above average odds for type 1 diabetes. She's got slightly above average odds for Alzheimer's, and she's got slightly below average odds for multiple sclerosis. All right. For breast cancer, she's got 1 risk variant out of 4, which is very typical. Prostate cancer, average score. Glioma, average score. Testicular cancer, she's got 7 risk variants out of 12. Looks like nothing was genotyped for Kito G. Nothing was found for Kito G. Was nothing found for Kito G, or does she not have any risk variants there? Let's look that up. Testicular. Nothing was found for Kito G, so nothing relevant for Kito G was found in the file. All right, so it's not that she doesn't have anything. It's not that she doesn't have any risk variants. is that nothing was found for keto G in the file. Alright. Because it would be really good if she didn't have any risk variants, but it looks like nothing was found in the file. 2 risk variants for C-like out of 4, which is really bad, but it's only out of 4, so it's not that bad in reality. No risk variants for GSS. 3 risk variants for Crohn's out of 18, but none of them are marked as important. And do we see anything else here? We do not see any uncommon risk variants anywhere else here. And for allergies, 4 out of 10, which is kind of high, but it's only out of 10, so it's not that big of a deal. Typically, it starts to get statistically significant when it's out of 20 or higher. All right. Let's look at the monogenic traits and find out if there's anything. So far, I haven't observed anything that's really outlier, like interesting in this result. Let's look at the monogenic traits and find if there's anything interesting to note. So warrior versus warrior, she's definitely much more of a warrior. 40% for warrior based on COMT, MAOA, and MAOB genotypes. She's more of a warrior. She's actually scoring warrior despite having GG in this variation of COMT Valmet. But keep in mind that she's got TT in this variation of MAOA, which is a warrior genotype. So she's, if you take into account everything, COMT and MAOA and MAOB, she's much more of a warrior. So you gotta take everything into account, not just this one variation in COMT Valmet, but you gotta take everything into account to get a good perspective of what your profile overall is. Are you a warrior or a warrior? You gotta take everything into account. I'm not sure if even the panel that I built here with like 10 or I think it's like 12 SNPs that it looks for in total. I'm not even sure if that's a good enough estimate of whether you're a warrior or a warrior overall. But it's the best that exists so far, I think. But you can't just go off one SNP and say, "Yo, I'm a warrior." That's not really that's not really representative, right? Because there's so much more that goes into it's such a polygenic trait. It's dopamine breakdown. It's such a polygenic trait. The way your enzymes work. Alright, so for dopamine D2 receptor sites in the brain, she's got a predisposition to intermediate number of the D2 receptor sites in the brain. So intermediate predisposition to such conditions as bipolar and schizophrenia. For levels of 5-HT and serotonin, she's got predisposition to lower levels of 5-HT and serotonin. So in higher predisposition to such conditions as anxiety and depression. Okay. Alright, looks like she has a predisposition to higher odds of autism. Alright. Looks like she has a predisposition to intermediate odds of lactose persistence. And the predisposition to higher level of empathy. Very cool. So based on these 1, 2, 3, 4, 5, 6, 5 SNPs, she's got a predisposition to higher level of empathy. Pretty cool. Now for lactose persistence, let's talk about this a little bit more. So based on these 2 SNPs, which is the Arab and the European lactose persistence mutation, she does not carry either. She doesn't have a single allele for lactose persistence in either the Arab or the European variant. But because of the way my trait predictor works when it comes to lactose persistence, the way I coded it, if you don't carry any variants for lactose persistence, what you're going to score is you're going to score intermediate odds. But if you do carry variants, you're going to score lower odds of lactose intolerance. That's the way I coded it. That's just the way it works. For hemochromatosis, she's not a carrier of CD282Y variant. Really good to see. Now, for diabetes, looks like she does not carry variants for type 1 diabetes. She has got this variant, which leads to 7-fold decrease in the risk of type 1 diabetes. Really good to see. Okay, so probably HLA gene panel is going to look pretty good. Alzheimer's, looks like she's got this gene which leads to increased risk of Alzheimer's, but there is no genotypes in the APOE gene. So looks like APOE gene, we're not going to find out anything there. For cardiovascular gene panel, looks like she's got a predisposition to higher odds of cardiovascular issues. But I remember the cardiovascular panel on the polygenic risk score page was below average risks. So that means the homocysteine panel is going to be good because the cardiovascular panel on the polygenic risk score page is a combination of the cardiovascular issues panel here and the MTHFR panel, or the homocysteine panel, I should say. I'm calling it the MTHFR panel because the MTHFR gene is the biggest contributor to the homocysteine panel by far. But it is the combination of the cardiovascular issues panel and the homocysteine panel together that contributes to the cardiovascular panel on the polygenic risk score page. So from seeing this result here, I am assuming that the homocysteine panel is going to be quite good. We can actually look that up right now, and we can actually verify that. And yes, it is quite good. So we can see that he is scoring lower levels of homocysteine, right? So that's all that we needed to verify. Because you can assume that you can assume that from looking at the results. It's very easy to estimate and make a guess from looking at the results because it's just math. You can calculate. You can do these calculations in your head as you're looking at the results because it's all connected together. Um, okay. So for facial morphology panel, it looks like she's got a European genotype in this variation of ADAR, European genotype in this variation of ADAR, but not a European variant in this variation of ADAR, which is very interesting. So no European ADAR alleles here. So that's kind of exotic, actually. That's really exotic. I'm not sure what caused that. That's not really typical for Ashkenazi Jews to have that. I don't think so. I don't think that's typical whatsoever. So that's not a typical European genotype in ADAR. Then there is genotype that leads to more upturned nose, smaller nose size, thinner eyebrows, and lower odds of missing teeth. Very cool. No micropenis. Mix of muscle types, which leads to being more likely sprinter than an endurance athlete. Looks like she does not have any risk variants for vitiligo in the HLA gene. In the HLA gene. And let's see what else. She is a carrier of two cutaneous albinism type 2 mutations, and she's likely albino. Wow, that is crazy. What did I just find? So she's got TT in this variation of OCA2, and she's a carrier of two cutaneous albinism type 2 mutations, and she's likely albino. What did I just find? That is insane. That is insane. That actually is insane. So this sample actually has albinism. This is an albino Jew. This is an albino Jew that I just found from Erfurt. I think I am the first individual here. I think I'm the first person to. Um, I think I'm the first person to find that there's a Jew from Erfurt who actually has albinism. Wow, that's crazy. This is good. This is gonna go in the thumbnail. That's insane. Okay, so this Jew has albinism. That's crazy. All right, for MCHFR panel, she's got most common genotype, lower odds of health issues. She does not carry any variants for familiar Mediterranean fever. She's got. I knew I would find something cool in this file. I swear I did not change anything in the file. That's crazy. So I knew I knew I would find something cool here. That's crazy. All right. Wow. So she's got albinism. That's crazy. Wow. That's so uncommon. She's got intermediate odds for various epithelial cancers. All right. Rare diseases. Let's look at the rare disease. She's got increased odds for ankylosing spondylitis. That's it. And Kahneman syndrome, no risk variants for that. HIV and AIDS panel. She's got this genotype in HLA-B, which is kind of bad, and it leads to increased susceptibility for AIDS and psoriasis. Let's look at the HLA genotype. Is that going to show up for the HLA-B? Yes, it does show up for the HLA-B. That's okay. That's cool. It's cool that I added this here. I think I recently added this to the trait predictor, actually. So for the HLA gene panel, she's scoring intermediate or slightly high odds of autoimmune disease, which is kind of bad. So that might explain the high score for lupus, which we saw earlier. And now for muscular dystrophy myopathy, she's scoring 0 risk variants for that. No risk variants for ADL were found. For color blindness, 2 risk variants for color blindness and OPN1 is W, but it doesn't matter because she's a woman. Women typically don't develop color blindness. She's got intermediate odds for obesity based on 1, 2, 3, 4, 5 SNPs. And she's got, based on 1 SNP, slightly below average just for syncope. For biotraits panel, let's see. Is there the typical CLTCL1 gene variant that I usually talk about? No, there isn't one. But she's got this gene type which leads to 2 times increased risk of severe alcohol withdrawal. Also leads to possible increased odds of ADHD. Very interesting. And lower predisposition to anger. That's also quite interesting to talk about. And finally, for the blood group panel, she's got blood type A. I'm seeing a lot of results with blood type A recently, and blood types that are not type O. So she's got another case of somebody with blood type. But this is insane. This is a sample with albinism. Not only does she carry a variant for albinism, she's homozygous for it. I don't even think this is a miscall because it's a homozygous call. Miscalls are typically heterozygous. In this case, it is literally a homozygous call for albinism. Let me find this again. Hold on. Let's look it up. I don't even think this is a miscall. It's straight up just the genotype that she had. So she's a carrier of two oncogenic albinism type 2 mutations, and she's likely albino. That is so crazy. This is going in a thumbnail. I think I'm gonna put a preview before the video that this sample carries two oncogenic albinism type 2 mutations and is likely albino. Wow, that's crazy. Thanks for watching. Make sure you leave a like and subscribe. To download this file, the link to download this file will be in the description of the video as always. And um, make sure you check out the description. In the description will be the link to download my trade predictor, to buy my trade predictor for $25. The sale is over, so it's back to $25. And thanks for watching my video. Thanks for watching. Make sure you leave a like and subscribe as always. Goodbye.